Good evening, sir.
Good evening, beta. Hello, everyone. Am I clearly audible to all of you? I hope my voice is loud and clear.
Good evening, sir.
Good evening, good evening, good evening. So, guys, just 1 minute we'll wait. Others will join and we'll start the class. All right. I think we should start.
Good
The-
evening.
Good evening, good evening. Beta. Others will join. So, what we're going to do today is now we will first of all recap. Actually, I mentioned in the group that the chapters or the topic which are coming is thermometry, that means temperature scale, where you have degree, Fahrenheit, Celsius, Kelvin, and the conversion and all. Those kind of questions will be there. Then thermal expansion, whatever we have done in the class, based on that only I have kept the question paper. Calorimetry, whatever we have discussed in the previous class, and some of the questions we will take in this class. And one more thing, I have avoided the question based on relative motion in 2D for a simple reason, because most of the students are not very comfortable with that. So I'm
Yes,
keeping
sir.
yeah.
The
So I'm
relative motion 1D, 2D means both.
yeah, I have literally avoided it. So the questions which you will get will be mostly on general 1D problems, calculus related problems, graph related problems, and the 2D I have avoided inclined projectile. But let me assure you, in the very next test, once we will done with those things, I'm definitely going to test you all based on this question topic. Is that clear? So I'm keeping a tab on the topic which I'm giving, and next test I will not going to repeat it. I will give some new type of questions so that you guys are well versed with all types of problem. Is that clear to all of you?
Yes, sir. Thank you.
Yes, sir.
Okay. So let us start with the question on calorimetry. Let me share it. It's a good question.
Sir,
Tell
excuse
me
me.
yeah, Bhavesh.
So the difficulty level of the paper will be moderate or easy or
It
tough?
will be moderate, I would say. I won't consider it's a tough paper this time, but be assured I will give all types of paper. Just like the how NTA designed the paper. This time it is moderate. But whenever I'm going to increase the level, I'll give a pre warning type of thing or information type of thing to all of you so that you will mentally prepared for the paper. Is that clear?
Okay, sir.
Sir, will there be projectile motion questions or not?
Projectile motion question will be there, but I have avoided the inclined projectile because some of the students have that problem. So inclined projectile I have avoided. Normal projectile, horizontal projectile, those kind of questions will be there.
Okay.
There will be few questions on vector also, properties of vector, right? So the paper is pretty much balanced. I have tried to give from all the topics. So there will be nothing which will be out of the syllabus or something which you are not comfortable with, right? So we'll start the class now. Can you see 22.7?
Yes, sir.
Yeah, that question, just go for it. It was a JEE Advanced subjective question, 2001. So all of you, please give a try. And use the data which is given in the question. Bhavesh, slightly less than that is the answer given, but I would approve it. Okay, it's pretty much fine.
Sir, how much is the difference?
Would say 20, almost 20 gram, I think. 20 to 30 gram. Well, I'm sure you have taken some approximation. That's why you're not getting the exact answer. Fine. All of you, I'm just giving one more minute. Hurry up with your calculations. Then I'll take this question on the whiteboard. The question here says that 0.1 kg of ice cube at 0 degree is placed in an isolated container which is at 227 degrees Celsius.
Sir,
Specific,
excuse me.
yeah,
Sir, is it 132?
132 what? Answer?
Yeah, sir.
No, no. You have given, wait, what answer you have given? Approximately 522 grams, no?
Yes, sir.
So I said the correct answer is 20 less than that. Okay, so here heat gain by ice will be heat loss by container. I am sure all of you are clear with this. Now ice, what will it will do? It will first melt. So how much it 0.1 kg, and what is the latent heat of fusion? 8 into 10 to the power 4. So 0.1 into 8 into 10 to the power 4 plus 0.1 specific heat, I think is 1000 given. So 1000, and final temperature is 27 of container and liquid. So into 27. That should be equals to mass of container. Specific heat is a function of temperature. So we have written that if such case is there, we will write like SDT. Where the final temperature, if I put it in Kelvin, it will be 500 Kelvin. Since I've already written lost, so I'll put here 300 to 500. Because I have already considered that the heat is lost by the container. So that's why I'm taking final temperature in the lower limit and initial temperature is the upper limit. This equation is clear to all of you? Please give me a thumbs up fast if you're clear.
Sir, I have sent an answer. I have not calculated the final value, but I'm
Yeah,
getting
it's
this
pretty much correct.
Okay, sir. Thank you.
Okay, Konika, Himanshu, Isabel, everyone, Aditya, Parinjya, Shakti, clear everyone? Yuvraj, clear?
Yes.
Yes,
What-
sir.
What we have written over here?
Yes, sir.
Yes.
Okay, so now just calculate this. So I think that if you calculate this, this will be 8,000 and this is 2,700. So you'll get 10,700 here. Mass is M. Specific heat equation is given as A plus BT. So I'm directly writing the final answer. It should be A. dt integration will be T. 500 minus 300 will be 200 plus B T square by 2. And A and B values are given. A is 100, B is 0.2 into 10 to the power minus 2. So M into A is 100. So I will write like this. This is 2 into 10 to the power 4. Plus here I will take 10 to the power 4 out. So this will become 2 into 10 to the power 2 into 10 to the power 4. 5 square minus 3 square will be 16 by 2. If you solve this further, you'll get approximately 0.5 kg as the answer. Right?
Sir,
Yeah.
So I didn't understand why we integrated here.
Beta, specific heat is not constant now, it is given as A plus BT. You were there in the previous class when I told if specific heat is a function of temperature, we can't directly multiply it. So
Yes, sir.
actually, this was the first question in JEE history where specific heat variation with temperature came. Afterwards, there were many questions in advanced where they take this, but in mains, they have still not, they have started doing it that rapidly. But I'm expecting that very soon NT people will start using it. Arinjay, are you clear with this, beta?
Yes, sir.
Okay, so guys, are we comfortable with this variation of specific heat with temperature? There is no problem now? All of you clear?
Yes.
Yes, sir.
Yes, sir.
Okay, let me take another example. I'll explain the concept first, then I will take the question. Suppose we have a bullet, and this bullet obviously have some velocity and it have mass. So it have kinetic energy, right? How much kinetic energy it will have? Half mv square. Now this bullet and this concept has been utilized many times. In advance, they have asked once or twice, and then mains people will have copied it. This bullet hits a target. Let's say it hits the box and then it comes to rest. So what happens? Obviously, the energy of the bullet has lost, the kinetic energy is lost. So that energy must have gone somewhere. So in question, they will give you that X percentage of kinetic energy is converted into heat energy. And that percentage will depend on the question. It could be 25%, it could be 50%. Depending upon whatever percent is given, we will write like this. Now, heat energy means that the temperature of the bullet will first rise and then it will melt, right? So if suppose this metal, it is made of lead and it has melted completely, bullet is completely melted. So we can say that the heat energy, we can calculate the heat energy. How we can calculate the heat energy? That initial temperature is Ti, its melting temperature is final temperature. So we can say that the mass of the bullet, specific heat of the bullet, or the material of the bullet into final minus initial. This is the rise heat required to rise the temperature of the bullet. Plus for melting, how much heat is required? Mass of bullet into latent heat of fusion. Is this point clear to all of you? That how we are comparing the energies of
Yes.
kinetic energy percentage, which is converted into heat form, because bullet will get heat up because of its own kinetic energy. So this is how we're gonna write the equation if such question comes in play. Are we clear with this? Because
Yes.
next I'm going to give one question, and there was many questions in JEE Mains which came recent year. So let me give that question to all of you. Okay, just one second. I have discussed the concept because I want all of you to get the answer. Can you see question number 4? Everyone?
Yes.
All right, go for it.
Question number 4, right, sir?
Yeah, 4. The bullet question. Bhavesh, no. Isabel, just check your answer. It's close, but not exact.
Okay, sir.
Let me say one thing. Half mv square, where velocity you are taking in meter per second, will be in joule. And whatever you are calculating on the other side is in calorie. So you have to make a conversion, whether you convert calorie to joule or you convert joule to calorie. That's why this conversion factor is given in J is given. No, she is not that.
Okay, sir, I'm checking.
Hmm. Take your time. Just give me a correct answer. Guys, how much the bullet is losing? That is absorbed by the obstacle. So the remaining heat is remain with the material of the bullet. I think you guys are making mistake there. Let me again clarify it. Obstacle is taking, this bullet is having 100% of energy, let's say. Out of that 100%, this obstacle is getting 25%. So how much the bullet is left with?
Yes, sir, I got.
What's the answer?
Shri, wait.
I did it using the one which you told now. I would corrected it.
Yeah, Shri, you now got it. Good.
Yes, yes, sir. When you told me to change, then I will.
Huh.
Yeah,
Yuvraj, I think you have to change your answer after this explanation. I think most of you are taking 1/4 as the total of kinetic energy as the energy received by the bullet, right?
yes, sir.
That is the point why this question was good, because they want to check the alertness of the candidate, right? Look at the way how they have framed the statement. They want many of the students to make this mistake that they will take 25 as the heat absorbed by the bullet. No, It's the heat absorbed by the obstacle. So bullet is absorbing the remaining. Now I'm expecting others also to give me the answer first. Still Isabel, it's not near to the correct answer. No, Aditya. Yuvraj, correct. Isabel, you are near, but slightly less than what it should be.
Okay.
Shall I take this to the whiteboard now? I think I have given enough time. So here, as I already explained, 3/4 of half mv square, right, should be the energy. Aradhya, correct, beta. And that should be equals to ms delta T plus latent heat of fusion. Now, obviously, here mass will get cancelled. So we can easily write V equals to root of, I think this 4 and 2 will make it 8. So 8s delta T plus 8L divided by 3. Right? Now here comes the point where we have to be careful. While putting the values, we should write 8 into, what was the specific heat given? 0.03.
0.03.
Okay. So 0.03 into the conversion factor, what we have 4.2, because I already told this is in joule. So we have to convert this whole thing on the right side in joule. And what is the change in temperature? It was 27 to 327, so 300. Plus 8 into latent heat of fusion. How much is that? 6 calorie. 6 into 4.2. Okay, guys, one more thing. Calorie per gram or kilocalorie per kg is same thing. So that is not an issue for us. Divided by 3. So you can calculate 8 into 0.03 will be 0.24 into 4.2 into 300. So I think that approximately will get 302 point something and 4. And this is 48 into 9.2. This is 441.6. The whole thing is divided by 3 and then take root. So this is coming as 441, 3. This is directly we can write 744 by 3. This is 248. Just one sec. Have I done any mistake here? Wait. 92. I think this part. This is 201.16. Sorry. So we'll get 504 divided by 3. So we're getting root 168. Now root 169 is 13, so I'm taking this as 13 meters. Guys, I have done the whole calculation just for the one thing because I know many of you got stuck there only. Are we clear now? I usually don't prefer doing everything because I feel like students should do it. But are we clear with this question?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right. So now I'll take some of the PYQ questions in recent JEE mains paper. Okay. So let me share those questions here on the screen. I'm sure that most of these questions you guys will get it. So just one sec. Can you see the question on your screen?
Yes, sir.
Yes, sir.
Okay, go for it. Shri Vita, correct. Good. Guys, I'm not giving any kind of hint because I want all of you to understand this question from your point of view. Bhavesh, correct. In the question of bullet, we use kinetic energy as heat energy. Here, which energy we gonna use? Isabel,
Potential.
yes. Everyone, I'm giving 1 minute. Quickly finish this, then we'll move to the next question. And this question, by the way, came this year's April attempt, means the latest attempt. Evening shift, 8th April. India, correct, beta? Good. Here, let me take it. Loss in potential energy equals to gain in heat energy. Simple. What is loss in potential energy? mgh. What is gain in heat energy? ms delta t. M got cancelled. GH by S is delta T. G is 10. I think 200 meter is the height. And specific heat, 4200 in terms of joule, sorry, joule per kg Kelvin. So delta T. So I think delta T you'll get 0.48 Kelvin. Is this clear to all of you? Tell me fast.
Yes, sir.
Are we clear with this, everyone? All right.
Yes, sir.
Just one sec. To the next one. Look, the question we took, the bullet question, how old question was that, huh? And look at the 2025 JEE mains paper. Is it a similar question?
Yes, sir.
Means if you have done that one, you could have easily got this question, right? That's why the old advanced questions are very important. So everyone, please go for this question and get me the answer.
Done, sir.
Yeah. So guys, I'm giving 1 minute. Everyone finish this. This one, the calculation also is pretty easy as compared to the one which we have done.
Sir, I have sent the answer.
Yeah, just one second. Check. Isabel, check your answer. Aradhya, correct. Bhavesh, correct. Shri, correct. Isabel, I think some minor mistake you have done. Check. Till I take it on the whiteboard, I was expecting others also to give me the answer for this. Arinchia, correct, beta. Good. So here what they are asking is bullet initial temperature is 300 Kelvin and it will go up to, Isabel, correct now. It will go up to 600 for melting. So can I say Q should be ms delta T plus M into L, and Q is given to us as 625. So 625, and here we are having, if I take mass common, so specific heat is given as 125. That into 300, because from 300 it will go up to 600, and latent heat is given as 2.5 into 10 to the power 4, right? So it's always better to write both in the same form. So we can take this 125 into 3 plus 25 0 into 10 to the power 2. So I think this will be coming as 62500. The mass we get it as 610 gram. They want in gram only, no? Yeah. Is that point clear to all of you?
Yes, sir.
Everyone, are we clear?
Yes, sir.
Okay. One sec. Let me take another question. Go for this one. Just one sec. I think I have something wrongly written. Just one sec. Let me just. This should be. Yeah, now it's fine. One sec. I think this type of question we have done in the beginning itself of the chapter. Isabel correct. Bhavesh correct. Shri, correct, beta. Aradhya, correct. Just 1 minute. Others also, please quickly finish. Then I'll take this question on whiteboard. Okay, here for this question, Aditya, correct. The steps will be -10 to 0, then 0 to 100, then 100 to 110, and at 0 there will be melting, and at 100 it will be boiling. So we will have Q1, which is mass 10 to the power, just 1 sec, 10 to the power -3. Specific heat of ice is 2100. So we'll write 20 to the power -3 into 2100 into 10. Arinja, just check your calculation. Q2 will be 10 to the power -3 into latent heat of fusion. So that is 3.35 into 10 to the power 5. Q3 is 10 to the power -3 into 4200, I think, 4180 into 100. Q4 will be 10 to the power into latent heat of steam, which is 22.5 into 10 to the power 5. And lastly, Q5 will be 10 to the power -3 into specific heat of steam, which is 1920 into 10. Is these heats are clear to all of you? How I've written all these 5 heats?
Yes, sir.
Yes, sir.
So just calculate and add, I think 3043 joule you will get. Second option. So those who didn't get, I would advise, please, after the class, you do one more time calculation. I'm sure you'll get the answer. Better you take 10 to the power -3 and 10 to the power +3 so that it will become easier for you to calculate. Okay. So this question will solve like that. Let me take another question quickly. Okay. So here in this question, they are saying that this is the condition. A block of ice at -10 is slowly heated and converted to steam. So which of the curve represent quantitatively this phenomena? So let me slowly drag down so that you can see all the curves. Question is clear to all of you?
Yes, sir.
So I'm slowly dragging it down. The first curve you can see it's starting like that. Ice at -10 slowly heated. Qualitatively, which graph makes sense? Steam at 100, that is the final.
So could you scroll up once?
Yeah.
Sir, you can just zoom out so we can see all four.
I can't, but this actually this website I can't zoom out. It's not a PDF.
Okay.
But there is a reason why I'm directly sharing this because I can't clip this question and paste it on the whiteboard. Aditya correct, Shri correct. Isabel correct. Guys, they have given one point which you have to, sorry. Arinjia correct. Qualitatively means you don't have to worry about the values. Just is it covering all the fundamentals? That is what you have to think. Aradhya correct. Look, for any such question, we know that there will be two flat lines. Is that clear to all of you? Because at two processes, the temperature will remain constant, melting and boiling. Are we clear with that? So wherever we are getting two flat lines, those are our probable answers. In first graph, we are getting one flat line here, which might be or which surely represent melting, and one flat line here which surely represent boiling. Because at melting and boiling, the temperature must be constant. Here we are getting only one flat line. So that's why this is not possible. Here we are getting again one flat line and very weird kind of graph where the heat supplied is 0 and temperature is increasing. That is not possible. You need heat for the rise in temperature. Here also the problem is we are getting two flat lines. Is it possible to raise the temperature of the body without heat?
Sir,
Is it possible to raise the temperature of the body without heat being supplied?
No, sir.
no,
Not
sir.
possible. So the only graph which is making sense here is the first one. Is that clear to all of you?
Yes, sir.
Yes, sir. Yes.
All right. So I think we have done enough in calorimetry. Now I want all of you to just revise whatever we have done. You don't need to do anything extra. Prepare for tomorrow's test. And if there is any doubt regarding the test questions and all, I will take it on Monday. Is that clear? And from Monday, we'll start heat transfer. Everyone clear?
Yes.
Yes, sir.
Yes,
Yes, sir.
All right, everyone. Thanks for joining. Take care. Good night. And I'll see you all in the next class.
Thank
Bye-bye.
you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.